Hi there, this is a video about triangle congruence using SSS and HL. Let's first talk about SSS and what that means. So SSS stands for side-side-side congruency theorem, okay? And what this means is that let's say I have two triangles and let's name them triangle A, B, C, and triangle D, E, F. Okay, and let's say that what I know is that AB is congruent to DE. And let's say that BC is congruent to EF. And let's then say that AC is congruent to DF. All right, so let's write those out. And so what I have is that each side of a triangle is congruent to another corresponding side of another triangle. And what I can now say, because that if I know that all three sides are congruent to all three sides over here, then what I know is that I can say that triangle ABC is congruent to triangle DEF. All right, so and that's why it's side, side, side. So if I look at this, I can go, well, I have a side, and a side. I have a side, side, and side here. Knowing that information, all right, that all my sides are congruent to corresponding sides over here, I can draw the conclusion that these triangles are in fact congruent. So let's write out a definition for this. And that definition states that if three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. All right, and that's the side-side-side triangle congruence theorem. The next triangle congruence theorem is HL, which stands for hypotenuse leg. Now, in a right triangle, okay, and a right triangle means that one of my angles is 90 degrees, so I have two right triangles here. And what I know is that if I take one of my legs, now the legs are the sides that make a right angle, and my hypotenuse is the longest side. So here are my legs, and this is my hypotenuse. Now, if I know that if the hypotenuses of these triangles are congruent and one of the legs are congruent, then I know that these triangles are congruent. And so based on this information, all right, we have to have a right triangle. And if we're just given two sides of that right triangle, one of them being the hypotenuse, and these two are congruent, and the same thing with one of the pairs of legs are congruent, then we can say that these triangles are congruent. Now I'm going to write this as triangle JKL is congruent to triangle MNO. All right, and so that's the statement that I can draw. Given this picture, and that's all the information we're given, I can automatically conclude that these triangles are congruent. All right, so by definition, what this states is that if the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the two triangles are congruent, and that's what I was explaining in this picture. All right, let's look at a couple of proofs. Okay, so in this proof, we're given some information. All right, we have this picture here. We've got two triangles, and I just drew it, so it's not perfect. But what we know is that AD is this segment length is congruent to AB. All right, so I'm going to come in here and let's talk about the logic. So these two segments are congruent. I then know that CD, this segment, is congruent to BC, this segment. So I'm going to come in here and mark those up. And what we want to do is prove that triangle ADC, this triangle here on the left, is congruent to this triangle here on the right. All right, so let's look at our statements and our reasons. All right, so I wrote out my T-chart, and I wrote out statements on the left side, reasons on the right, and I wrote out my two given statements. All right, AD is congruent to AB, and that CD is congruent to BC, and both of those are given. Now, the third statement that I can the conclusion that I can draw from this picture is that AC is congruent to itself, okay? So what I'm going to do is I'm going to come in here and I'm going to say that AC is congruent to AC, and that is the reflexive property. All right, and now here's what I've got. From one triangle to the next, I've got a side, and a side that's going to be congruent to a corresponding side, and a side. So what we can now prove, based on this statement, in statement 4 is that triangle ADC is congruent to triangle ABC. And the reason that I can make that statement is because of the side-side-side congruency theorem, okay? Okay, on the next proof, what I want to do is take a look at our given statements and take a look at our picture. So we've got that segment TR, this segment here, is the perpendicular bisector of QS. All right, so the TR is going to cut this in half and make a 90-degree angle. And we also know that QR is congruent to ST, okay? And we want to prove that triangle QRP is congruent to triangle STP, okay? So let's take a look at our logic here. All right, so what I know is that TR is the perpendicular bisector of QS. So here's what I know, is that this angle is going to be a right angle here. Same with this angle, okay? Anytime that you've got a perpendicular line, then all the angles here are going to be 90 degrees. All right, so this is 90 degrees, that's 90 degrees. It's also going to cut QS in half. So I've got that these two segments here, QP, is going to be congruent to SP. Then I've got that QR is going to be congruent to ST. All right, and that's all the information. So actually, this, I don't have to really do much because I already have a hypotenuse and a leg that's congruent to another hypotenuse and leg, and we can automatically conclude that those triangles are congruent. So let's write out our statements and reasons. Okay, so once I've written out my statements, my given statements, all right, what we want to do is conclude what we can do here. All right, so one of the things that I want to do is I want to jump in here and say that angle TPS is 90 degrees. All right, so that was the first thing that we did. So I'm going to say that angle TPS is equal to 90 degrees. Now, the reason why I can make that statement is because of the definition of perpendicular bisector. Okay, we're going to use that a lot here. Then I can say that in my fourth statement that angle RPQ, so RPQ is also 90 degrees. All right, and the reason for that is the same thing. Now you can say definition of a perpendicular bisector. You could also say vertical angles. Whatever you want. So that's the idea. The other thing that we can say here is that QP in step 5, that QP is congruent to SP. And the reason that we can say that is because, again, it's the definition of a perpendicular bisector. All right. And so from here, I know that we have right triangles. All right. Based on this, I know that I have a hypotenuse. The hypotenuses of these triangles are congruent and a pair of legs are congruent. So then what I can then prove from this is that triangle QRP is congruent to triangle STP. And the reason that I can make that statement is because of the hypotenuse leg congruency theorem. So that's all I got for this video. Hope you guys enjoyed it. We'll see you soon. Thanks. Bye.